Hi, recently I had to test out a switch. I thought I had a bad switch because my lights weren't coming on and I knew the lights were parallel. So usually if you've got multiple lights on one switch, you'll lose one light at a time because they're parallel and not in series. So I thought maybe it was a switch, so I tested the switch. So I'm going to show you in this video how to test the switch with a multimeter. And then I've got this test battery I use for testing, and I can hook up the switch and test it with that. Before we move on to show more of the switch testing, I'd like to take an educational break and talk about continuity in single pole, single throw switches. What is continuity? Continuity is the ability of a circuit to carry electrical current. For a light switch, the circuit can conduct electricity when the switch is turned on. This is a closed circuit. When the light switch is turned off, the circuit is open, no longer conducting electricity, and the light goes off. For our testing, we are looking at a very simple single pole, single throw switch that will either be closed when the switch is turned to the on position or open when the switch is turned to the off position. Here you can see when the switch is off, the circuit is open and the light is off. But when we turn the switch on, the circuit closes and the light comes on. Now back to switch testing. To do this, we select continuity on the multimeter. So for mine, it's right up here, and you've got what looks like an ohm, and you've got what looks like sound. So on mine, you have to go through and select the sound. If you can see it up there in the top of the screen. All you're doing with continuity is you're taking your two probes. If you put them down and you hear a sound, you know that electricity can run between the area you're testing with the two probes. If I touch the two probes together, I get sound. If I take the back here and I touch them together, or I touch it to each of the connectors, it's off, so I get no sound. If I turn it on, if the switch is working, so I just press it, I should get sound because it should be closing the circuit to the two wires that would connect to the back of this, and I do, so at least in that sense this is a good switch. Okay, now I'm going to test my switch again, but this time I'm going to use a test battery. This is a little battery. I got it on Amazon. It's a 12-volt battery, so that's what we're running in our RVs, right? So it's a 12-volt, but it doesn't have a lot of power. It's not like your house batteries or your chassis battery, if you got a chassis battery in your RV. It's much smaller, but it pushes out the same volts, so that's all you need to test something, unless you're testing a big appliance that pulls a lot of amp. This battery right here will allow you to pull 7 or 7.5 amps, which you can test a lot of things with that amount of amps. So what I'm going to do is I'm going to hook a light up to our switch, to the battery, to check and make sure this switch works. So I can hook this light here is going through the negative, and I'm going to hook to the positive. I'm going to hook this up to the switch. And on this line, this is just a little test line, I've got a fuse, inline fuse, and I just do this for safety purposes because sometimes I get into testing more complicated things. So right here we've got our light. The switch is in the off position. So I just hit the switch, turn it on, and we've got light. So we know we have a good switch here. Light, no light. So let's just talk about safety of this little test battery I have, or any battery for that matter. This is 12 volts. It's smaller. You're not going to pull a ton of amps like you would a car battery or the house battery in your RV. But you always have to be safe. You never want to short out between the positive and the negative terminals on the battery. So for example, I would never want to take this jumper wire and connect across the two. I do have a fuse in this one. I would blow the fuse immediately because there's no resistance and you're going to get as much amps as this battery can push out basically through this wire. Whenever you're building a circuit, you're testing something, you need a load on it to make sure you're not shorting out. So the load in this case is our light, and we do have the fuse for the extra protection. So we connect, and you can connect it in any order. I'll connect the positive to the switch and then the negative through the light, and I've got power, but I've got to be careful how I connect it, because again, I don't want that metal coming across and touching the positive. Light, off, no light, light.